Good morning. Hope you can hear me all right. And you can see my RStudio window. Hi, Jeffrey.
Yes, you can. Yeah, we can. I think we can see your windows. Good morning.
Okay. Let me share the link to the Etherpad. We'll use the same shared doc to share notes. Please sign in at line around 180. Yesterday we were talking about fragile Excel, and I found an article. If you remember, during the COVID times, there was some test data lost, and there was some issue with Excel version mismatches, and some older version could only hold 65,000 around that records in one table. So some part got truncated, and it took a while to realize what's going on. Let's wait for a couple more minutes. In the meantime, feel free to unmute if you've got any questions about yesterday. Also, follow along in the doc. Further down below, there are little polls about were you able to download the data? Was it possible to load a package? To do that, you can type this library tidyverse command in the console window and press enter to run it. In the little warm-up exercise, what are the characteristics of tidy data? And tidyverse refers to set of tools working with data in a tidy format. So see if you can remember a couple of points from yesterday. So we're thinking about tabular data made of rows and columns. Yes, the shared document should be linked from the ARCHER2 page, but yeah, thanks. Welcome. Please sign in the shared document. And let me know if you had any issues installing R or RStudio. In most cases, it works out of the box. Sometimes you might need to install some manual dependencies, or some dependencies manually if they were not in the system already. In terms of schedule, it will be like yesterday, so we'll have a session until 11 and then half an hour break and then finish at 1, restarting at 11:30. So there is one data file combined, CSV. There's no need to download it manually. We will download it programmatically later on. And in terms of materials, we will stick to the data analysis and visualization in R for ecologists lesson. And those notes are available online. So in terms of tidy data, there was something about rows, about columns, about cells. Perhaps something about missing data. So that you might see a message about conflicts. That's okay. This means some functions have the same name. And those will be masked by ones from the library. Okay. In terms of tidy data, so feel free to unmute if you don't want to type. So let me add it to the shared doc. So each row contains an observation, a single observation. Each column represents a variable or a feature. And then each cell contains only a single data item. In some cases, you might have something else, but this makes it more difficult to analyze. And units and missing values are treated appropriately. In terms of dates, we also need to consider date format, and we've seen some ways yesterday. that some formats lead to problems. So we'll be in the shared doc from line to 20, and this morning session will be about introduction to R. It looks like everyone got a working version now. If it's for something, that should be fine. Yes, so we are using the shared doc to share code and exercises and so on. And for now, I'd ask you to open the window, like the RStudio, which is an IDE, Integrated Development Environment, and we'll be working in this window or set of panes. So I want to ensure that everyone's got RStudio, and if you type library tidyverse into the console window and press enter, it will run it, and there should be no error. Let me know if you experienced any errors. So briefly, what is R? So R is a statistical programming language developed from the S family of languages, and it's open source and freely available. It has a CRAN or C comprehensive R archive network, which is over 5,000 various packages or libraries. Those are packaged parts of code that you can use, functionality, statistical analysis, and it's very comprehensive, so it's really useful for data analysis as well as plotting. And tidyverse is one such meta library. It's a collection of libraries for working with tidy data, and we'll look more at that, what's a data frame and what's tidy data and so on. So let me see. So usually you would need to install R first, because RStudio relies on an R installation. And depending on your operating system, you might need to follow different setup guidelines, as in the materials. So Annie, you've got some trouble. It might be only a warning. Can you open the RStudio window and see the same pictures I'm seeing? Briefly before we start, I should also emphasize that R is a well-developed, actively developed language with a large community of experienced developers who are also very helpful online, like on Stack Overflow or and mailing lists. R itself is a multi-paradigm language. This means it supports some features of object orientation. It can interface with C++ and so on. So it's also Turing complete. This means for the purposes of programming, it's a fully fledged general purpose programming language, so you can implement anything with it, strictly speaking. It can help with reproducibility, so we'll be looking how to automate data analysis steps and create little data analysis pipelines, and hopefully by then you'll be able to apply it to your own research. R is extensible in the way that you can create your own libraries and then share it with the community. it's designed to work on various data types, sizes, and shapes. So and it's designed for statistical analysis. It's also cross-platform, so some of you might use Windows, Mac OS, or Linux, and there are versions for each of the platforms. Okay, so I've got my editor open here. This is where we will work most of the time. Okay, if some stuff is building, it might compile things on the fly, then you will see a lot of output when installing a package. Okay, in terms of RStudio, so this is the development environment. It builds on, uses the R interpreter in the background, so it's an interpreted language. It will take the commands and run them one by one. So we've got the menu at the top where we can open files or create a new project. When we open an R file, so R code is saved as with the extension .r for later use, but we can also type something. For instance, getWD. That's a predefined function that we can use to check the directory in which we're working, our working directory. This is where we will save plots, for example. And we can also see it here on the files. This is home. And here I've got the data as a subfolder. And this is a good practice to structure your directory structure in a self-explanatory way and separate code and data, for example. But also you might have raw data and data that you're working on in separate directories. Are there any questions about RStudio? So there's the code pane showing the source code. Hope the size is large enough. This is the console. This is where we can see output of running some code. So we can use RS calculator, for example, and Control R or Command R on Mac. We can run an expression, and this will be evaluated, and we'll see the result in the console. We also got some other panes. I will come back to them as we interact with them. So one showing the environment, it's showing if we have defined some data objects, they will appear there. History of commands, so we can check what just happened recently. So install packages is something I have done to install a package, for example. So if you haven't done this, you could install a package, but we'll come back to that. Okay, so usually we work in projects. So let's create a new project. We'll navigate to the file menu, new project, and this will open. You can save a previous workspace. I'm not going to save it because it's empty. We'll start with the new directory. Or I might actually start with an existing directory. Let's see. Okay, let's start with a fresh project. So new directory, new project. So find a place where you want to place it. So I sort of have the directory ready, so I'll reuse the one that I've got, but you can create a new one. And you can check that you would get WD, that the working directory is set appropriately. You can download the code handout if you want. It has some code pre-filled as comments. So comments are prefixed with this hash symbol. Okay, let me paste some notes into the shared doc. And also a link to this code handout. So this will be a separate R file. And you can add it to the directory. And it should appear. For me, it's under data. So I'd suggest you create a subdirectory, a data subdirectory here by, for example, clicking create a new folder. So I'll create, let's say, a folder for documentation, and then the folder will appear, and you should see it in the files pane. Okay. Was everyone able to create a project? So it makes sense to separate raw data and data because we don't want to work on the raw data to risk compromising its integrity. This is, for example, OpenRefine as well. It always works on a copy of the data, as we've seen yesterday. We can also set working directory to a different place, but let's not do this just now. So if you've got this plus, this means there's some missing input, and you can press escape to escape that. So or complete the input. So if I write get WD, like this. So this plus, the prompt changes, and this means the R interpreter is still waiting for some extra input from me. And when I complete it, it should be complete. So we can interact through this console with the interpreter for one-off commands. So if I type 1 + 1, I can see some output here. Okay, let's see. Okay, let's spend a few minutes on the project part. So if you go to File, New Project, New Directory, New Project, specify a directory name in a place where you want to keep the project, and create. This should create a new project, and this will have kind of an empty project. There you can create a subdirectory within this file pane and download the data, for example, into the data subdirectory. So for me, it looks like this. So in terms of the materials, we are in the ecology lesson at the interacting with R section. There's a useful cheat sheet, which is a summary of R Studio commands. I'll post the link in the shared document. So for now, let's see. If the project is not working for now, this is okay for the purposes of the exercises. As long as you can see the console and you can run some code, you can create a new file instead of a new project and save your notes in the file. So hopefully you can still type along. So we want to have this as an interactive session. This means I will type in my window, and you can type along to the same, and we will keep notes in the shared doc about key bits of code. And there's also, I've posted a link to this to the pre-filled code file if you prefer to work in that. So it has some comments with some steps that we're going to go through. Okay, first let's think about getting help. Let's say we want to know what getWD function does. We can prefix it with the question mark, and then we could see help will appear in the help pane on the bottom right. You can reset the position of the panes for your convenience in the globals menu, but here, but we're not going to do it just now. We'll stick with the default layout. So then this help system has some description of what a function does, how to use it, sometimes an example. We can also call it directly using this help method. This is in general the syntax for function calls in R, and we can think of a function as a set of instructions, or rather like a sequence of instructions that takes an input and produces an output for us. And it has a name, so that's the function name. The parentheses are required, it's part of the syntax. They signify that whatever goes into parentheses will be taken as an input by the function. And the output might be a message, which is a side effect, or it might produce a result. So for example, there is a function called C for concatenate or combine, and we can use it to create vectors. How to use it? So for instance, it can take a list of values, comma separated list, and if we run it, it will create something that has a type of list. This is the way the RStudio prints values. It will choose some useful way to print it. So here it shows the values. And then we can apply another function to a list of values to get the mean of those, for example. So it takes a vector, and mean knows how to deal with vectors. Specifically, R is a vectorized language. This means most functions are defined in a way that they can work on vectors as well as on single items. Any questions about how to get help inside R? There is a neat function called tab completion. So if we start typing and then press tab, the editor will suggest from available function some function that can be used. This can be useful to if you want to check if there's a max function. Let's scroll around, and yes, there is one. So that's a quick way to explore what functions we've got. In this environment, an error message will also be visible through some kind of visual aid like this. So here it suggests something is missing. The suggestion might be slightly cryptic, but in this case, we're missing the parenthesis part. Any questions so far? Okay, so to run this line, I place my cursor on the line and press Control Enter or Command Enter if you're on Mac, and then the interpreter runs it and produces output in the console. Can everyone get this behavior? Okay, great. So sometimes we want to ask online. About why something is not working on the forum, and then this session info command might be useful. This sort of provides information about the R environment, the R version, some packages used, and so on. So some people might ask for the output of this. Also, there are some great free books online about data science and R, in particular by Hadley Wickham and Garrett Grolleman. Okay, there are some messages in the chat. So Control S or Command S will save the file, then this red will change. So if I type something, if it's red with a star, it means there are some changes that are unsaved, and Control S can save it. To clear the screen at the bottom, if you press Control L, it will empty the output to like clear it up a bit. Okay, let's have a look next at get some more experience interacting with R using named objects and function calls. We'll also inspect contents of variables, but first play around a bit with the interpreter so we can use it as a calculator. So factorial is a function, and we could get fairly large numbers. In R, we can create labels for values, also called variables, but those are not to be confused with statistical variables. So here, for example, if we define weight in kilograms as 55, and we use this arrow symbol instead of assignment symbol, as common in other programming languages, to define a label, weight kg, to refer to that value 55. And we can see on the right here it appears in the environment. And if we change it and rerun, then the value changes. So that's a mutable variable. And this also means that the order in which we run our code is important. If we run it interactively, line by line, and mix up the line order. All right. Jeffrey, would you be okay to keep track of some of the key commands in the shared doc? This way, if people something, they can also refer to that document
Yes,
as
I'll do
well
that.
as to this code handout that was shared previously.
Yeah, I'll do that. Yes.
Thanks.
Sorry, when I run that
So-
variable, it doesn't come up in my environment.
So we call those variables, but they're known in other languages also as objects. So sometimes we might use the terms interchangeably. And the idea is that an object is a computational entity that contains some data and has some associated operations that work on that type of object, where type defines what are the legal values for that object. So we can check the value or get the value by using the symbolic name instead. We can see here. So we can refer in different other contexts. If we, let's say, mistype a value, we get an error message. And in this case, this says object with this name is not found. And we can also confirm there's nothing in the environment with that name. So this is likely a typo. Any questions about the variables or objects? Now we can also perform calculations using, and we can use tab completion here. So I start typing weight, press tab, and then if it's unambiguous, it will autocomplete completely. Otherwise, so we multiply our weight by 2, and the new result is what we've get. And if we want to keep it, so store it, we might define a new name, and then we can refer to that value that we just computed by that name. As a reminder, to save the code, I press Control or Command S to save, then this file will be recorded. We can reload it later. Do you remember what this hash symbol stands for? To the end of the line, you have seen how this text was marked green. Can someone type in the chat what the meaning of this is? Other operations are supported, like division, multiplication we've seen, we can do addition, and so on. Okay. Let's do an exercise. This is a comment, by the way, so if the line is preceded with a hash symbol, this will not run as code. So the exercise is find a function to find the square of a number, to get the square root of the number. So a function that takes as an argument a number and produces the square root of that number. Any suggestions? So I would suggest it's useful to follow along, to type all these bits. This way you get the first experience of interacting with this R interpreter. So this is not a particular example, it's only showcasing some of the features of the language just now. Did someone find them? So far what we have done is we've looked at RStudio, we've introduced R as a programming language and its merit, and now we're exploring ways to interact with RStudio or with R through RStudio. And we have seen the console, the pane where we can type code. We have created a project. We've got our project structure with code and data. And now Paul has a suggestion for a function, SQRT. Yes, that's correct. And we can check, is it a function? And in fact it is. So if we type question mark function name, it will display help for the function, and then it will also show some examples. Sometimes the usage is more clearly defined in the usage section. So we could try run it. And we can also pass a variable name as an input. And then this will refer to the value we have assigned most recently. And we can check in this environment pane what value it has. Are there any other questions so far? Sometimes I might not straight away see the chat, but I'll check on it regularly. Okay. So we can check, use args function with the function name to check what arguments are expected. So square root takes one argument, for example. Another function is round. We can use it to round the value. So let's take a crude approximation of pi. Okay, so we can see this can also take a named argument called digits. Apart, and x is usually referring to the data or the main argument. So we can type round the input, and then we could say digit equals 2, and we can see how we get a different output this time. So R can deal with numbers, decimal numbers, integers, with string values. So there are some base data types that are predefined. To illustrate how we can use named arguments, if we forgot the order in which the arguments should go. So it is possible to use all names arguments. And this way the function will still know what to compute. So we can see we have changed the order of arguments, but this time we needed to provide a name for the second one because it's in the unusual order. Normally it goes, the main argument goes first, and then there is no need to name it. This x is a different x compared to the names that we've got in our global environment. This is only for the purpose of the input list. Okay, we have seen the combine function already. So let's review the vector data type. Vector is how we can build collections of items, a series of items from basic data types. So let's say if we take a few numbers that represent weights of rodents, because this is the, in the background, this is the ecology data set we are thinking about. So we've got some weights in grams, and we could see it's a numerical vector that has 4 items, and it appears in the environment now. R can also deal with characters, so if we need some labels, we can use the same combine function, and a character string is enclosed in this quotation marks, in this double quotation marks, so, and can use as labels elsewhere, for instance as column headers. If we run this, Control Enter or Command Enter, then it also should appear in here, and we could see it's abbreviated as char or character, CHR, 3 elements, And each of those is itself a sequence of letters. So how could we check programmatically the length of, let's say, our animal vector without looking at the environment pane? Any suggestions? So we might be able to use a function. So it's a bit self-describing, but this is how we might try it first. We might think maybe there's a function called len, and then we run it, and we'll see an error that this function can't be found. So this might mean, yeah, we forgot to import a package that contains it, or it simply doesn't exist and we mistyped it. So there is a function called length, and we can see that it gives us the length of the vector. So what will we see if we type length of weight g? Okay, let's say we made a mistake. In this case, the variable is not found, and this gives us a good clue that we need to change our code and rerun it. We can run a whole section of the code if we mark this section and press Control or Command Enter. Then we can see it runs both lines, one after the other. There is a function called class to check what class of value we've got. Sometimes we can check it to make sure we've got a data frame or something that we expected. And there is a function called str. This is used to check the structure of it might not print the whole data set, but kind of the main information about types. And you can see it's the same as we can see in this environment pane. Are there any questions about function call syntax? So we have function name, parentheses, and inputs, and we might have named inputs. And usually the main kind of data input goes in first. And it's often called X. Okay. So how else can we use the combine function? We can combine named values as well. Or we can add new values to a set of values. So for instance, to add a new value to to our weights in grams, we can use the combine function, which takes things we want to add. So we've got a list of values and a value, and the combine function will create. So if we only do this, so let's run just this part. We can see, sorry, just on a single line. What I want to say is, if we don't assign it back, then it will do something. It will produce a value and throw it away, and there is no output. So to actually print it, we might need to put parentheses around it. This will print the value. Oh, that's what I thought it should be. 1 second. Yeah, we can print like this. So we can call the print function to look at it directly, but usually we would assign it back to something, and this can be a new name, or we can override what's on the left, and this is why we use this arrow syntax also, with what's on the right. And what's on the right is the result of applying this combine function to those values, which will put them together, and then we can see now we've got a new value here. Or actually, we've got quite a few now. Okay. So every time we run this, it will add a new 9 to the list. So something to also be aware of. Every time we override, we change the internal state, so to say. So we could say these are atomic vectors. So these are the simplest compound data types. They're made from the base data types such as character, or if we check class of a number, is numeric. So it could be numeric, could be complex, and there are some other classes as well. For instance, and then we can build complex classes from those, such as data frames or factors that will, or lists that we'll see in a moment. Okay. So there is some subtlety with some implicit conversions happening when we use values of different types together. So let's do an exercise and explore. Will be on line 260 in the shared document. So I've pasted in some code there. So run each line separately, but first try to predict what will be the output of class for the returning value of those. And this will help us gain some intuition that if we get sometimes a slightly less expected type, yeah, what will happen? So I should mention that vectors can only be of one data type, so they're homogeneous. We cannot have a vector of numbers intermixed with characters. They will be converted to one common data type. So, and I'll type this also. So if we take a few numbers, but then also got character. So I see how it's still quite far removed from data analysis, but we need to go through the steps to kind of get the feeling for the basic features and data types in the language, because we will use them then soon enough. Okay, so if I run it, what do you think will be the class of num_car? Any suggestions? So we can, of course, run it and check, but often it's a good idea first to try and envision what will it be. And here what happens is we can figure out that character is a more generic date type, so everything will be converted to characters. So this is no longer a number, the first element. Another example is if we've got logical date types, so something like true and false are predefined values in R. And this will be numeric, so we can see that true will be changed into 0, and false, true will be changed into 1, and false will be converted to numerical value of 0. So some old codes might use this behavior to do some trickery, and you've come across this. This might look confusing, but sometimes a Boolean value might be used as an index, for example, or as a numerical value. How about the next one? So we combine logical value and the character. Any suggestions? Feel free to type it in the chat or unmute and yeah. And we can double check, yes. So something to be aware of. And I'll paste the rough directions of conversion. So logical will be converted to numeric to character, and logical will also be converted to character directly if they are intermixed. Okay, let's see. So we're at the section subsetting vectors in the materials. So we can access single elements using an index. So animals. This might or might not be what you expect. So some languages use zero indexing. But R uses one-based indexing. So the first element is at the index 1. If you come from C, for example, programming background, then first element might be at the index at position 0, or offset 0. This is a bit of a difference, but yeah. So we can get a single item by using this bracket index notation. So, but there are other features, so we can use multiple indices with this combine notation. So we need a vector of indices, then that's why we need the combine call. So we can see how the order has changed based on the order of the indices in our index vector. what happens if we access an item that's beyond the edge? So in this case we get NA, which is a special value representing a missing value. Yes, good point, Andrew. It's something this array indexing is different in R compared to Python. So if you've got some Python experience, you might intuitively use an approach that will behave differently in R setting. So another feature is called conditional subsetting. We can specify a vector of true and false values, specifying which values to select. So if I specify false, true, true, then I should get red and dog. I hope this makes sense. And this is useful because we can have various conditions that we check. And the conditions will produce Boolean values. And those can be used to subset. So this is quite useful. So for instance, we can select all weights that are larger. So the condition would be weights G that is larger than 50. Or let's use smaller than 50, just have one value. Oh, sorry. This is smaller than 90. So you can see how different conditions create a different conditional vector, but the vector always for each element it would check the condition. So we now can use it for selecting elements from itself based on its values. So we can subset this. So if we wanted to drop all the 90s from our data set, we could assign this back to weight G, and then all the 90s would be dropped. In fact, let's do that. Okay, so you can see they disappeared from the environment, but this means we can overwrite data. So if we had some data and then we might by mistake overwrite it, then it will be gone. We can't get the 9s back again. We need to recompute them the way we did before. And now we can combine. So we can combine using logical operators. We've got greater, something like greater, equals, or less than. We've got and or. So for instance, we can select values in a range by, and we'll find a better way later on using tidyverse functions. This base R way is also useful to know about. So if we get no values, then we get an empty vector. So let's unpack this. we've got a conditional expression that's made of sub-expressions. So, and for each value we can check that this is true and this is true, then the whole expression will be true, otherwise false. So if we run only this part, in the console, we will get, for each value, we will get true or false, whether this condition is true or false. And then we can use the vector of true and false values as selection. So if it's false, the item is not included, otherwise it's included. So we can see we got 60 and 65, the true C values. Any questions about this? I'll just copy some operators that can be used. So the ampersand stands for logical AND, and the bar is for logical OR. For the logical OR, either left-hand side or right-hand side needs to be true for the whole expression to be true. So there is also one handy function called in. It's a built-in function. So if we select animals, in a list, so we specify values to which we try to match, and then the in function will check if the value from our data vector is in the set. So we could see that red is in here. So we'll go to one true, because yeah, we check mouse is not in here, rat is in here, dog is not in here. Okay, a quick question. So what will, if we type 4 larger than 5, will it be true or not, and why? It's a bit of a trick question, but yeah, best way to check to run it. So this is something also we want to encourage experimentation, because we don't work on raw data. We are not risking losing our data, so we can really try and see how things work, and if we break things, we reload the data set again. Yes, so this will be an alphabetical comparison. That's why we get a true. Because 4 will come later, so it's ascending order. So we have seen this word NA, that stands for missing data. still considered logical, but it represents, it's not there, but it's used consistently in many functions. But some functions don't work on data that has NA values. So we're in the missing data section. Let's define some height. Okay, by the way, if I want to remove something from the environment, I can use RM. Be careful removing things because they'll be gone forever. But let's say I mistyped it. I want to name it height, so I remove it using RM. This is RStudio specific, so it will work in the RStudio project here. So once this gets quite convoluted, maybe we'll remove something. So if we run min height, we get NA, because this NA value will sort of invalidate the whole vector, and we don't want this to happen. So we can specify that missing values should be removed. And many functions take this argument, and then NA remove to true. So first it will select all values that are not NA and then use those for calculation. We can check again with the question mark to see that help specifies what type of arguments can be provided. Sorry. So you can see it needs to be true or false. There are also other useful functions. As you start using R and look more into documentation, you might discover others. So there's one useful function that is NA, which can be used to decide whether something is a missing value or not. And you can play around with various values to see how functions behave. That's why this console is quite useful. So a quick exercise. Extract non-NA elements from heights. How would you do this? Using the conditional subsetting? Okay, so the hint is that the exclamation mark is expression and is logical inversion. So not true is false and not false is true. Any suggestions? Feel free to drop it in the chat or in the shared document, even better. Okay, I'll just add some notes to the shared doc as well. Any suggestions? So we can use this isNA function, but if we only do height isNA height, so we will get those that are missing, but instead we want those that are not missing. So we need to invert this logical expression using this not notation. Any questions about logical and comparison operators or conditional subsetting? So what we've seen so far is ways to define variables. This means labels for values, and we can update those values by assigning again. And there we use this arrow symbol. I wonder if this works. Okay. So we can even apply help to operators to check. And there are other ways to assign, but let's stick with the arrow notation. So this is close to this mathematical notation of left-hand side is defined by the right-hand side. We use RStudio to manage our projects and both data and code. We can use hash symbols to create commands like so. And we have also seen basic data types such as vectors, numerical, logical, and character values, and learn to interact with RStudio through these panes. Any questions about this section? Otherwise, we'll move on to look at what the data frame is, what factors are, and how to load the CSV file into data frame. Feel free to type into the chat or into the shared document or unmute. Sometimes online it feels maybe I've lost a connection and it takes a while for me to realize that it happened. All right, so we'll also look at date formatting. So let's get the data, and we will download it using a download file command. I'll copy paste it from the materials, but I'll also copy paste it into the shared document. So you could see this notation. There's a function called download.file. It takes as argument URL, so this is where the file is located. So, and then, okay, first let's create a data raw folder, because this is what this command expects. So we'll have also data raw. This is where we'll download it to. And we use slightly different link from before, so take note this number might be different from what I've shared above. So it might be slightly different, but this is what we'll do. And then it should say some message, it downloaded something, and inside the raw data folder now there is a file. Let's hold that you managed to get the data. Put a plus and a yes on line 280 in the shared doc, or let us know if there are any issues. Okay, also note this is, I run it kind of as a single unit, so it is split onto 2 lines, but it's run as a single statement. So if you've got an error, but you were able to download the files before, you should still be able to use that data. Yeah, make sure you've got all the syntax correct, so that there's the file name, and also paste the error message into chat if you've. So non-zero exit suggests it failed for some reason. So no such directory means it tries to write the raw data, but you didn't create a directory. So you might use a different directory. So yeah, to create the directory, I use the GUI. So to go create a new folder here and then data underscore raw. But you can also change this part. You can change it to data, and then it would download it to the data. Yes, so this equals dest file equals should have the argument part. So it specifies the file name at receiving end, like the destination file name. So you could remove this part and only use the file name, so it will be placed directly at the top level working directory. But we recommend to have a data raw subfolder in your structure, in your folder structure, as best practice. Yes, you can add a new directory, name it, and this should appear here. You can use it, you can edit using terminal if you use that type of thing. So you can type a bash command in here to create a directory. So you can see directory appear, and you can remove it again. Sorry. We're not going to go into bash commands though, but there is Software Carpentry has a lesson on bash commands if you're interested. Okay, so now we're at 11. Let's take a break now for half an hour. If it's still not working for you, I'm happy to stay on for a few minutes so we can fix the downloading part. But hopefully everyone we'll have the data ready so we can import it after the break. Thank you.
Can you use bash commands in the console?
Not in the console directly, but in the terminal sub-window.
Got you, yeah.
But this depends on your operating system. So I'm on Linux. I've got the terminal commands, and we could see this rproj file. This is the Rs project description file. It's also seen here.
Yeah, that works for me in the terminal.
Okay. Paul, are you happy to unmute and tell me how far you've got? Is it the download file bit that didn't work?
Yeah, it's I'm still just getting the error message that I posted above. I'm not sure where to create the raw data folder.
Did you create a project initially? So through new project, so that in the files you've got this rproj file, and here you can click on the new folder, give it a name, and it should appear here. You can alternatively specify different paths relative to the working directory. So if you type getwd into the console, this should show you the absolute path to where your project is. Is it the place that you'd expect?
Let me just check. Okay, I've created the folder within the working directory called data underscore raw.
Mm-hmm.
But I'm still getting an error when I try to import the CSV.
For me, it looks strange that this kind of equals dest file equals part. It should be dest file equals, and the right hand side should be a string, so it's enclosed in this double quotation marks.
Okay,
and
I'll try and
directory
read this.
And the file name. So you could also try without this prefix with directory, then it will drop it into the top level directory. So if you remove this bit and rerun it,
oh, I've got it. So
it will
portal,
wherever it is. Yeah.
I think I've done it. Yeah, it's called portal data joined CSV.
Mm-hmm. Yeah. Yeah.
That's correct. Okay, excellent. Okay, I have it.
Great. Thank you.
Okay, thank you.
All right. See you at past.
Yeah, see you later.
Hello and welcome back, everyone. Hope you had a nice break. Let's get back into our intro to R, and we'll continue where we left off. I've also put a link in the shared doc to the materials. So we're starting with data section of the materials now, and it looks like everyone got the download to work. Correct me if I'm wrong. So if for some reason it didn't work, you can still go to the website, download the file manually, and place it manually into the directory where you want it, to be able to do the next section. So we will use a function to read the CSV file in from the tidyverse package, and to load a package, assuming it was installed, I'll write library tidyverse and run this, and then we can see some output that, because it's a meta package, so it's a package of packages, it loads various things like dplyr, ggplot2 we will use tomorrow for plotting, lubridates to working with date objects, and so on. And yeah, if you didn't have this, if it didn't work, you might need to call install packages first, and this might take a little while without this command sign, so just that part. And we'll use a function called read CSV. So we'll call the data frame surveys. This will be a label. Then we use the left arrow. Make sure to use read underscore CSV, not the base read.csv package, because it behaves slightly differently. And then we'll specify the same directory as an input where we save the portal data join CSV. And when we run this, we can see on the data section and the environment, the service has appeared, and it says it has so many observations of so many variables. And we can have a quick look. This is the output of the str. If we run str surveys, we can check the structure of this, and it looks roughly the same as this output. We can also view this. If we click on this table, we can have a little graphical preview, and we can see there are still some missing values in there, but we see the column got names and the values. We've got the date split into year, day, month, as we've done yesterday. And we've got some genus, some species, and so on. So this is some data for various plots, observed species. Let's have a quick poll at line 286. To see if there are any issues. Okay, if loading the data has worked, that's great. So this means we've got this tabular data set with 34,000 odd rows and 13 columns. We can check that by using dim of an object. So this will give us the number of rows and columns, and by convention, rows is shown as first value, columns as the second. What are data frames? For our purposes, they are tables or rows times columns objects, and they contain a series of columns, and each column has the same type for all values across rows. But we have checked the structure with str, so we can also use a function called encall check the number of columns, or nrow to check the number of rows. So this way we can check, do we have expected number of observations already? So if we expected 35,000, then we might see, maybe it's downloading the data. Any questions? Okay, let's see. There were some issues. Can you see the service after running this read CSV line? Can you see the data object appearing with the number of observations, and you can interrogate it using the functions? And you can click on here to get the view. This is the same as a built-in. You can see here it's called, this is a built-in function of RStudio, but we can pass a data frame as input, and this will show us a preview for few rows, few columns. So it's not going to show everything, but this way we can quick inspect a data set. Okay, great. So other functions we can use, such as, for example, head, will give us a few values in the console, but this fulfills the same purpose as visual inspection using view. We can see there are some types for the columns, so most got double as a value, and we might need to think whether we want to convert it to integers or not later on when we analyze data. And some were left characters, even though we might need to convert them as factors for the purpose of statistical analysis, so that they have some kind of categorical values. And we can also call summary on the file. This will give us a different kind of statistical summary. It might or might not be meaningful for the columns. I'll just copy this over to the shared doc. So hopefully everyone can check the dimensions and ensure that you've got the correct number of rows and columns. And this is already part of sort of exploratory data analysis. So there's a question about the name. Yes, we can choose the labels as we want. It should be descriptive. So something like data frame or DF, people often use it, but it's not as good as something that is more descriptive. But it's up to you. If it's only you who's using the script, you need to use a consistent terminology that you know how to interpret. And ideally, it has some documentation that someone else can also figure out what it means. But so combined is the file name, I believe, somewhere. We're not using combined. This is a separate data set we'll use later. So I've copied the notes, so you can sort of rerun this part from the notes, and it should do the loading. So let's check the class of the service object, just to confirm that it's something new. So it's got multiple hats and can put on something called TBL, so some sort of table, but the main interest of us for us is the data frame type. So, but we can see it's objects can have many guises, but as long as they have specific interface like rows and columns and indexes, we can work with them. So we can index and subset data frames in the same way we subset vectors, but we use two indices. So for instance, to take the first element, we specify the row and the column index. If we wanted six column first row, yeah, and then this would be the error if we try to access an object that was not created before. So we can select the whole column or the whole row, so by specifying only one. So if we select one row, if we don't specify an index, this will be a whole row. And we could see it's a table. So table is another type of table that's used internally by tidyverse, but it's a data frame. And it's one row, 13 columns. So it's what we would expect. Same we could do across rows. So only we can calculate the length, and this should so it's still one data frame. That's why it shows one, but it has all the rows. So we would need to use n row on the data frame. So usually typos are the common syntactic errors. Sometimes we might miss, let's say, comma, and we will still get some result, but it might be clear to specify our intention. We can also use vectors to subset, if we did before. So if we want the first and the second, and the third and the fourth column, we will get a 2 by 2 matrix. So this way we can extract a slice from the data set. And there are various other ways to subset, but we will then soon look at a different way to filter and select, which is easier to read, because here we're dealing with indices. We can use the column names. To select a column, let's say. Okay. Let's do an exercise. Next. I'll paste it into the shared doc on line 301. This is also in the materials, by the way. So create this new data frame service 200 containing only the data in row 200. Yeah, and then continue from that. So you can use nrow to extract a particular row. Let's spend few minutes on this. I'll be typing along as well. So remember, we put the row index first, and then we need the comma, and we specify no index if we want the whole row. Second part is to use nrow. Feel free to drop your suggestions into the shared doc. We're on line around 305. So there's one other part is to extract the middle row of the data set. Any suggestions? Please add them to the shared doc. Remember, n row gives you the number of rows, and this could be used as an index. Something along those lines. Okay, to get the middle one, we need to divide the result of n rows by 2. And we didn't talk about the minus notation. You can use minus to count backwards, but this is not very commonly used. So to save some time, I'd encourage you to look it up later. So let's skip part 4 and let's move on to factors. Any questions about subsetting or indexing? So R has a special class when working with categorical data, and that's called a factor. They're useful and they influence the way the data is structured, for example, in plots, which bar comes first and so on. And factors define levels, so the values that they can take. And they often behave like character vectors, but they're actually internally treated as integer vectors by R. So need to be careful when treating factors as strings and the other way around. So when we did the import the data, often the textual data is converted into a factor, but sometimes we need to manually convert it. So let's look at, it's another notation to select the column by name. This dollar notation. So we could see this X column is a text or like character based in terms of type. So what we could do is turn it into a factor. And this means we override it by itself turned into a factor, and we do it by this factor function. So now if we rerun the structure command, we could see the type has changed from character to factor with 2 levels, but also it has still some missing values. We can also check the summary. This way we can have a quick count of so how many observations we've got for different levels. So this way we can check how many missing values, for example, we've got. And internally, there will be a corresponding index or an integer value for each of the levels. We can check the levels now. I'll copy paste this. So we've got 2 levels, and we can also check number of levels with the n levels function. So this way we can also check if we've got the expected level number of levels in our data. Okay, let's do an exercise next. Changing. Yeah, we'll change some other columns to factors and answer some quick questions. So first, change the columns taxa and genus in our data to a factor. And then we've got some questions. For instance, how many rabbits were observed? Let's see. I'll also copy this into the shared doc. We are on line 313. Yeah, and feel free to post your answers there as well, so we can compare. Any questions otherwise about the factors? So we can use the str function to check that the change in fact was successful. When copy pasting, we need to be careful here. If we forget to change parts of the line, we might accidentally override our data with some other part of the data frame, and this might succeed because the dimensions and types fit the description. So be careful when copy pasting things. Anyone found out the number of rabbits? So now we've got the okay, with the summary we can check some numbers with some sparrows. number of rabbits is 75. Let me know if you've got the same. And for the last question, how many different genera are in the genus column? Okay, I'll check. Yeah, we'll check the number of levels. $26. It's not the only solution. You might have found another way to check this. So feel free to share if you've got another way to do it. Yeah, sometimes we want to convert the other way around. So we might take a factor and get the characters back, maybe for some display, but we need to be careful because the conversion can be trickier when numbers, dates are involved, and the recommended way, for example, to get numbers from years, we cannot simply use years, we need to use the levels. So as an example, so let's say so we've got a factor that represents some years. I'll quickly remove some values here. I have a bit more space here. Okay, now year appears here. It's a factor with levels. If we wanted the numbers themselves, if we go straight to numeric value from the factors, you see we'll get something odd looking because of the way how internally things are stored. So the levels will be this, but they will be stored in numerical order, I think, differently. So instead we need to jump through some hoops in this case. This is not to memorize, it's to be aware that when factor conversions are involved, we need to pay extra care. So we cannot generally take factors where we would expect numbers and hope this to work. So here we do get the numerical values of the levels this way. So we've got the levels indexed by the values. think for a minute about this. So we use the values to index into the levels vector. And it works because the factors have a numerical value corresponding to those that translates to an index into the levels. So first we obtain all the factor levels using the levels function, then we convert them, and then we access them using the year factors values. Any questions about that? So let's see if we can see a plot. So we're using the base R function, but this can be used to quickly visually inspect data, and the plot will appear on the plot tab, and if we zoom in, this will pop up as a window, so it won't be visible. But if you do it, you should see it on your screen to pop up. Charlotte, there was the question about differences of index. There is no difference. The dollar is a shorthand notation for the square brackets and column name notation. You can use both. So I think dollar was introduced as a convenience notation later on historically, but both works. So let's have a quick poll. Are you able to get the plot? We're on line 328. It's not exactly publication quality plot yet, but we'll work on this tomorrow. Okay, keep those pluses coming in. So what we have also seen in the data that we had some missing values. And we can add missing values to a factor using add_na function. So let's see. So we can see now we've got an extra level. But if we wanted to name it, we can set set the label for the level as like so. So we use the index here directly and the character set. Okay, my bad. Okay, now we can see there's 3 levels. So this way we can also show the missing values as part of this. As a quick exercise, rename F and M to male and to female and male. Shouldn't swap those around. Okay, it's a quick one. So if you recreate the plot, what happens? So let's spend a few minutes on this exercise. So plot is a built-in plotting command, but we will use ggplot, which is part of tidyverse later on. Please post your solutions into the shared doc. We're on line 347. Okay, there's some issue with the plot function. Jeffrey, would you be able to have a look if you can find any info on this error message? So plot window. Alana and Annie, could you put your code into the shared doc as well, so we can have a look? So it might be that you forgot to convert to the factor first. I wonder if plotting something else would work. Something like service taxa should also show some numbers. I think Genus will not very informative until we fix the labeling, but at least show something. Okay, so make sure to check with str that it's a factor if you're trying to plot it as kind of this histogram style plot. And this information is also visible in the data display in the top right in the environment window. So we can see some things are factors. and plot will plot those as kind of histogram, as that's a common way to plot categorical data. But here we could see it's slightly broken still in the display, that not every bar has a label and the labels are sort of scattered around. But we'll look tomorrow at how to customize plots and make them more publication ready. Okay. Okay, would you like another exercise? Sort of manually creating data frames? Or shall we move on to formatting dates? Let's have a poll. Okay, we're on line 348. In a nutshell, you can create data frames by specifying the vectors directly. But you need to be careful to get all the syntax correct. But let's say, example, it needs to be of type data frame. And then it needs to take the vectors that represent the values. So this is roughly the structure how you would approach it. Need also this semicolon between the vectors, and now we can see. We still need to fix the column names, but so we've got data frame as a list of columns, and columns are vectors of the same type. There's some conversion that might happen if you've got something else here. Let's say something like this would convert the first one to strings. Okay. Can I see a few more pluses, please, in the shared doc? We're trying democracy, but we're not core-rate yet. Okay, thanks. Yeah, let's move on in this case. You can still come back to the exercises and find them in the materials and try them again. Let's say in a week's time or in a month's time, thinking about Ebbinghaus, forgetting curve. Most of the stuff we will forget, and we will need to remind ourselves by using this actively. So spaced deliberate practice and repetition is useful for that. And starting to apply it to your own data is one of the best exercises you can do. Okay, let's see. if you remember, when we loaded tidyverse, it also loaded something else, and this is the library that will be used. We can also load it directly by typing, and it's helpfully already suggested. So packages also have help, so that helpfully defines the functions that are suggested. Sometimes the functions can be a bit cryptic, but often they have some consistent style scheme to them. LibreDate can deal with intervals, periods, durations, and dates, and can chop dates up and combine them. So it's very useful. Let's see. Some libraries have more detailed tutorial style helps. Let's see if LibreDate has one. This is called vignettes. And this often gives more coding focused introduction, how to use something. For example, we can use YMD to get a date representation from a string. And we can also work with date times and time zones and so on. And so these vignettes often have a nice introduction, like walkthrough through basic functionality. So we're not going to go through all of this, but this is to show that LibreDate is quite powerful package and can help us when working with dates. So hopefully everyone was able to load it. I've posted also a link to a cheat sheet, which is a PDF describing some of the common functions. Let's create a date to play around with the YMD function, which takes a description. In this case, years, month, and days, and then let's do some warnings. That's interesting. Let's see what the structure of my date object is. So it's has its own type, which is something LibreDate understands. So Unix timestamps. I think this package will also be able to handle timestamps. You mean something like nanoseconds since 1st of January 1970? I think so. I think have a look in the cheat sheet if you can spot anything. I don't remember off the top of my head, but I think there are functions so you could specify as an extra argument that the string should be interpreted as a Unix timestamp, and then it will create a date object from it. I'm not sure it's the YMD function that can do it, but one of those. Let's have a look at the help. Yeah, this is another thing. Using a language requires to read a lot of kind of help documentation to figure some things out. But in general, R's documentation is quite good. Yeah, so there might be some other base function that can do it as well. And we can play around, try actually see if YMD will give something sensible, given something looking like Unix timestamp. Yeah, maybe it's not quite right.
Yeah, just skip ahead. I'll look up it. I'll look it up later.
I think he's having some network issues. Sorry.
Hello everyone, can you hear me back? Sorry, there's some network blip. I don't think that RStudio crashed my browser though. So yeah, let us know if you found anything about the Unix timestamps. I'll have a look later if I can find anything. It's quite a common use case, so I expect that Lubridate can handle this. But the details I can't remember at the moment. Okay, what we can do is also to paste things separately. Yeah, let's change it to the second and the second.
Kenny, I think the screen is not shared yet.
Oh, right, sorry. How about now?
We can see it now.
The question is, does it change if I type something? So we can specify a separator as well. Okay, didn't like it.
Is that because you haven't specified it as a string with that separator? You've just given the individual elements in your MyDate.
One second. Oh yeah, so there needs to have a paste function in here. Paste function is building a string from subcomponents. Yeah. So if we check the help for paste, that's quite often used in ARM to kind of combine strings together to get another string. Okay. And if we can check this structure of my date again, it says the date format, and this is the string representation of it. And we can then extract particular parts of that. I wonder if this will work. And no. Okay, but we'll figure this out. Okay, I need to look into the cheat sheet myself. The document didn't update. The shared document, I'll paste it again. Strange. Must have been a blip with the shared doc server. So have a look at the cheat sheet. Can someone find how to extract a subcomponent from a date object? So I've posted the cheat sheet into the shared doc. So exercise. Extract from it. So this way, maybe we read a string from a CSV file representing a year, maybe in this style, and then we can create new columns and extract years, months, and days as we did yesterday in Excel or OpenRefine to do it in our using Lubridate.
So you use the command year? Yeah.
Thanks, yeah. So it's the obvious one. Oh. Yeah, typing needs to be exact. Okay, this is the briefest of overviews. So looking at the cheat sheet, you could see it's possible to convert between different time zones, and you can find closest month to the date or things like this. So there's a lot of functionality. And on the second page of the cheat sheet, you can see working with intervals, and so you can take two dates and subtract them and get a new date and so on. So Lubridate is quite powerful, and if you work a lot with dates, you can convert things to milliseconds, microseconds. However, I didn't see the way to go from Unix time.
The top of page 1 of that cheat sheet.
So okay, so as date time, we'll give a date object, and then and once you got the date object, you can apply all those functions on the date object. Yeah, we could try this. You could take the number from the cheat sheet and try call the function. So let's see what type of object this is. So this is something called POSIX-CT. So it's a different type of date object. So maybe we first need to make a date from it. But hopefully this function knows how to do it. Okay, now we've got date, and we can get the year from that. Great. Okay, so I hope this illustrates kind of a common approach to working with the documentation. So look at the help first. If there's nothing in the help, play around with the values a bit, and then look at the cheat sheets or online documentation. And if this doesn't work, there's always Stack Overflow, where by now probably every question has been asked at least once. But if not, you also can ask a question providing a simple example with the error message, and usually people reply quite quickly. Okay, that's dates. So what we've seen is how to read in data from a CSV file into R, and how to subset it so we can look at summaries across rows or columns. We've come across factors and how we need to be careful when converting characters to factors and back, and how factors are represented internally as numerical levels, which have also some kind of label string representation attached to them, but internally treated as numbers. And factors are useful to plot, for example, categorical data. Okay, this concludes this section. Are there any questions?
Sorry, when you
Otherwise,
did the DT as date time, how did it get that date from those numbers?
how as date time got it from the numbers? This is the internal implementation details. So we sort of rely that this function works as intended. So it could figure out that this format can be interpreted according to some standard
Yes.
POSIX.
So the numbers in the bracket is effectively the number of seconds that have elapsed since midnight, the 1st of January, 1970.
Okay, thank you.
It's called Unix time, and actually we will run out of space for Unix time by 2030 for 32-bit integers. So this might be another
That's similar to the
year
year
to K moment.
the year 2000 problem as well. So I was involved with some of that work. And 32-bit integers is 2030 is the limit for 32-bit. 64-bit is okay. Goes on forever. Well, for most people's lifetimes anyway.
Okay. So no other questions? I suggest to move on and get started on the section on manipulating, analyzing and exporting data with tidyverse. So we looked at base R functionality, which is part of the language, and lots of scripts and code will use this notation, so it's important to be familiar with it. But tidyverse provides some functionality that allows us to do similar things, but in a more readable and reproducible way. So I've also posted a link to the materials. We'll move to the next section and look at functionalities from tidyverse. In particular, dplyr and tidyr packages. We'll look at the pipe operator, which allows us to structure our data analysis pipelines in a natural style. And then let's see how far we got, and then we'll probably continue tomorrow with summarizing, grouping data, selecting columns, and filtering data based on conditions. So this way we can sort of zoom in on part of the data set we're interested in, and then we could get a summary of that numerically, but also then use ggplot to plot. So what I mentioned, dplyr and tidyr, there are different packages that have efficient implementation of handling of data frames and transforming data. So there are also cheat sheets for those. I'll also paste those into the shared doc. These cheat sheets I find quite useful as a kind of brief introduction of what a package can do, and RStudio looks after tidyverse. I think it's called Posit now, the company, and they also start also using Python, so that RStudio will have more Python support, I guess, over the time. So by looking at the cheat sheet, we could see dplyr allows us to filter, select, and slice data. So instead of using the indices, we can use column names and conditions. Okay, so we can continue working with the surveys data set. And the verbs we will look at are select, filter, mutate, group by, arrange, count. So common operations And if you're familiar with databases, you might see some similarities here as well. And we'll see on the last day how SQL verbs are also matching to some extent with the tidyverse verbs. And these are actions we can perform on the data. For instance, we can use select to select some columns. So select takes as input the data, and then column names, plot ID, no, yes, that's it. So we can see we get an intermediate date frame with all the rows and 3 columns by those names. But because we don't save it, it will be thrown away. Alternatively, you could say, use the minus notation to say, for example, everything but plot ID. Then you could say minus plot ID, and let's say to check the dimensions. So we could see we've got 1 less columns selected. Okay, let me check the chat. Oh, right, yeah, there's some subtleties about times and dates, so you can go fairly in depth. Right. Okay, so we can also assign the result of select give the variable name, and then we could refer to that subset later. So this will be a separate object. Let me remove a few things to clean up. Maybe it's the name, sorry. Okay, just use one. There's some more convenient notation for this, but for now, let's keep service. So if I run this, we get the new subset that's got only the 3 columns. Any questions about this? Is about select? Okay, let's have another example. This time filter. You can guess what filter does. thinking about the conditional subsetting. So we provide a condition using a column name. So all years that equal 95 from surveys, those rows will be selected. So it's kind of selection based on rows rather than on columns. So it does filters things out. And give us again a date frame or table, which is for our purposes synonymous. Let me copy this over to the shared doc. Any questions so far? So tidyverse, in particular dplyr and tidyr define this kind of verbs we can work with, but so far it's not very convenient because we sort of need to always save it to another variable, and we quickly grow large number of variables in our environment this way if we do it. But there's a better way we'll explore briefly now and more tomorrow using pipes. So as an example, so if I type surveys, everything that has weight smaller than 5, and our metadata data dictionary from the data should give us a clue what the units are here. SML for small, I guess we can just call it small. And we select some subset. So species ID. So this is an example of how it can become a bit unwieldy if we don't have the pipes that we'll introduce in a second. Yeah, so this starts growing quite quickly and it becomes a bit tedious to navigate, and we run out of names and so on. So not ideal. Another way you might suggest, okay, but this is all intermediate data structures, so what we can do is sort of wrap one into the other. But then the difficulty is we get this long lines that we need to read inside out. So we've got the same result, but now we need to read it from data goes inside and we unwrap it kind of from the inside out, which is not very nice to use or difficult to read. So instead we'll use some called pipe symbol from Magritte R package, which is part of tidyverse, and we can press Shift M or Command Shift M to get it. Sorry, Control Shift M to get the symbol. So this is the pipe. Control Shift M on PC, or on the Mac it's Command Shift N. But you can also type it as a percentage sign, greater sign, and what pipe does, it can take something and pipe it through a pipeline. So let's see, how would we express the line above using a pipe? So we take the data and we feed it into the pipe, and the flow is from top to bottom, from left to right. So something familiar to us in the Western world who read left to right. So this way we can write it as a sequence of pipeline operations in the data analysis pipeline, and this way we can incrementally also build pipelines step by step. Now I did write it in one go, but you can see how this data flows through the pipeline. Surveys will be used as an input to filter. Filter will select the rows. The result of that will be taken as an input of select. And this will give us an intermediate data frame of the dimensions that we would expect. So we can see it's the same as this. And now if we want to save it, we need to assign it to a value. So now we've got some ugly looking name, but we're running out of time now. So I'll just quickly write it down. So, and that's intro to using tidyverse verbs, and we'll come back to this tomorrow. If you want, you can do a quick challenge exercise using pipes. But if you need to rush off, please spend a minute to give feedback for today's sessions. We're on line 383. Let's do one up, one down again. Another way to give feedback could be a 2x2 matrix where we look at presentation and content separately and keep and proof for each of the subsections. But let's keep it simple today. We can do 2x2 at the end of the whole workshop. So please provide some comments what you think worked well and what could be further improved, and hopefully it will be. Thanks for sticking around. Hopefully you learned also something about Unix time. Thanks everyone. If you've got any questions, I'll stick around for a while longer. And if not, have a nice rest of the day, and I'll see you tomorrow at 9:30. We'll do more of tidyverse and then also plots using ggplot2.
Thank you. See you tomorrow.
See you then. Bye. Thank you. All right, yeah, I see there's some feedback about tidyverse issue. I hope you were able to solve it. Otherwise,
Yeah, I was able to solve it. Took a while, but it was the underlying operating system that was missing some like.
yeah, so it might need something like zlib and make and all the kind of machinery that is used to
Yeah.
build the libraries.
Yeah.
And yeah, it can be a bit cryptic, the error messages. It just says can't find something.
Yeah.
And then the name is maybe not the name. Like you would need for your operating system to look which library it contains. So yeah, it can be fiddly, but I'm glad you solved it.
Yeah. So I did fall behind a little bit, but I'll catch up this afternoon, ready for tomorrow.
Okay, sounds good. Thanks.